everyone. I'm Sujata Vishnuraj, editor with Manufacturing Today. It's my pleasure to welcome you all for an engaging discussion on manufacturing the future, the next era of design, collaboration, and innovation, brought to you by Manufacturing Today in association with Micropoint Computers and NVIDIA. Design is organization. Design is the image. Absolutely. Design is a story. Design is the material that we end up with. Design is the object that you then are selling, promoting, or making someone look at. Converting a concept into complex, high technology product is an involved procedure consisting of many steps of refinement. As the design evolves, the choice becomes interdependent, taking on the character of an interwoven historical chain in which later decisions are conditioned by those made previously. Imagine then that a production or manufacturing engineer enters such detailed negotiations late in the game and asks for changes. If the product designers accede to the request, a large part of the design may simply unravel. Many difficult and pivotal choices will have been made for nothing. Where close calls went one way, they may now go another. New material analysis and product experiments may be necessary. We are here today to discuss and listen to the subject matter experts on how in future design will play a more fundamental role in integrating products and services and enhancing customer experience. Allow me to introduce our panel members today. We have Chinaraja Sisubalan, who is the Vice President and Engineering and Quality at Flex. He's responsible for running engineering and quality operations, supporting several Flex sites across the world. He manages the engineering change management, product lifecycle management, environmental compliance, and manufacturing engineering. We have Girish Haganu, who is a senior executive with extensive expertise to lead a business unit with excellent skills to acquire new customers and introduce new products, maximize revenue and productivity, and ensure future growth and profitability. We have Prasad Pandit. He's a strategic leader with 23 years of experience in cross-industry platforms, which includes extensive field work, managing construction processes, geospatial services, pre-sales, sales management, geos business plans, etc. He's a strong preacher of virtual twins, digital mock-up, building information modeling, building experience management for manufacturing, etc. Next, we have Jacob Peter. Jacob is an industry veteran with over 30 years of experience. He leads the engineering areas responsible for vehicle computers, ADAS, safety systems, infotainment system, and automotive electronics in Bosch. Jacob is passionate about the possibilities that connectivity, machine learning, and analytics will bring to automobiles and topics that fall on the cusp of classical electronics and digital like telematics, ADAS, and IoT. Nikhil from NVIDIA, he is not limited by form factor. In his almost 8 years stint, Nikhil has been promoting NVIDIA solutions for complex workflows to manufacturing, auto, media, and entertainment, ONG, ITES organizations with a national and global presence. The pandemic has given him a new charter to ensure the work doesn't stop for his resource-hungry customers. Senthil is an engineering professional with around 29 years of experience and proven track record in product development, test center, application engineering and sustaining engineering, project management, new product development, product testing, prototype development, and customer interaction during new product development, etc. Neeraj, who is moderating today's session, he has around 21 plus years of experience in working with Fortune 500 companies across the globe. He has varied experience in project management, process safety management, operations, capital project management, and contractor safety management. He has worked with leading companies in the past like KPMG, ITC, L&T group companies, and has been helping companies in various transformation initiatives. Neeraj led multiple projects across strategy and operations, leveraging digital in different types of industries. Thank you all and welcome back for a very engaging session. Over to you, Neeraj.
Thank you, Sujata, and thanks everyone for joining. Indeed, a very apt topic and a very engaging topic as well. Now, I think before I get into the questions, I think manufacturers today, they are enjoying, right? I mean, they're enjoying a lot of the continuous advantages coming from different innovative products. And but still, the battle of time to market to kind of produce better products faster, cheaper, and not to mention profitable is still there, right? That's the constant race which we're all battling in, right? Now there are few concepts, of course, which is transforming, our entire industrial design paradigms, and there are also the fundamental changes in which we kind of design and build products in today's age. Uh, and while the need is to reduce the time to market, but then it's becoming more products and services, and sometimes products and services combined. So I think if I just reflect on my own journey 20 years ago when I started my career, I think this DAWA, we used to call it DAWA, design anywhere, build anywhere, is still a vision 20 years ago. And, it was not something which was physically happening, even though it was a concept everybody dreamt of. Uh, but I think we have moved a long way from there, and now DAWA is more or less a reality in many perspectives. But I think now we have moved from design anywhere, build anywhere to also service anywhere, right? So product development has moved much ahead, and it's not just design, it's manufacturing and its services all tying in together, right? And in the process, products and services, and the line is getting quite skewed. Where is the product, where is the services, and everything is connected. And what is really helping us connect all of these things are few fundamental concepts, and I think this esteemed panelist will help us decipher many of them. But I think I just wanted to lay down a few concepts which is really transforming the whole next generation of design and collaboration. One is digital twins, right? So I think the power of designing or building something virtually, in front of you is very empowering. It wasn't there before, but now it's there. So you don't have to just imagine. You can just live that, and then look at how software platforms can help you help you design. And what is really helping them is this advanced technologies of Internet of Things and all of those new emerging technology, right? The second thing is AI. Now AI is one of the fastest growing technology everywhere, I think. And I think at the heart of AI, I mean when we talk about Industry 4.0, is AI coming to play, where we are leveraging AI, and we'll talk about some of those to our panelists as well, how engineers are leveraging AI to produce or design better products faster, better, and how it gives you that flexibility for the next generation of design, right? Generative design, again, I think we'll talk about it. It uses AI, right, where software is actually helping you create design solutions which probably our human mind could not even conceptualize, right? So it's basically AI becoming your partner in the design process, and you have algorithms helping you or supporting you to create or co-create your design elements as we go along, right? So I think there are many leading companies, aerospace companies, automotive companies, manufacturing companies, who are today using generative design in a very normal, in a day-to-day way, to be able to kind of achieve larger objectives of improving the design. 3D printing. Now 3D printing has brought in a completely different paradigm, right? So I think additive manufacturing is transforming the complete, the different way, and the entire way design has to be done, or the entire way the business has to be done. So that's fundamentally changing. Then virtual reality and augmented reality. So all of these things, if I just put it all together, it really puts in a totally different or a new era of design, collaboration, and innovation, which is what we're going to discuss today. Getting on to the esteemed panelists now, I think my first question would be to Jacob. And Jacob, yes. So and I think I'll probably leverage that AI question to him first. So I think coming from Bosch, so AI has been, of course, very discussed topic. I think it's not a new thing. Everybody knows about it, what it is, how it is. But let us, we all would like to understand from you that when you look at this generative design and making products better, how does AI really help, and what's your view on that?
I think most of the things that we consume on a daily basis, whether it's searching for a website or where you're talking to your Alexa, behind it is AI. So whether you know it or not, AI is a part of our lives already. That being said, for us, it plays it on two levels. One, as a essential function in our vehicles and in our vehicle design and the components of vehicle design, where I think NVIDIA also plays a big role in it. I think you guys are also making a lot of silicon which goes into the fundamentals of autonomous driving. So computer vision and multiple sensors being integrated and providing the possibility of a car steering and maneuvering through busy streets is something all of us dream of. It is somewhere down the road, but at least on the level 3 and level 2 plus, it's already on the roads. This is something that we work very closely, and we do a lot of work around computer vision. But that's on the essential feature that the product encompasses. But beyond that, AI will have a lot of impact around the processes that we use, whether it be development processes. In development processes, we are looking at essentially how we code the modeling that comes in. So we are looking at low code or no code coming in. There's AI working underneath to just understand your intent and let you code or the machines take over code. So that would be a disruption in the development process itself. As we go forward, if we look at Industry 4.0 and how we look at our manufacturing, there are certain stations where we have completely done away with the stations through modeling and the and mode of where there's a lot of data collected which acts to take some decisions. So earlier we used to have these tests that were done, testing stations in the complete manufacturing lines, which were done away with in using some techniques of AI. But last but not least is some amount of predictive analytics that we do, so that one of the use cases that we were doing with one of the OEs was can we predict a failure or a possible failure in the field by looking at early indicators of warranty data and diagnostic data that comes from vehicles. So the possibilities that AI offers are immense. The underlying part is how well are you able to get the data that's required, the diversity of data that's required to make right decision even for an engine, and the training methodology that we adopt. Because of the training methodology that we adopt or the data set that we use is not the right one, you could end up with wrong decisions and a lot of challenges in the field. So it's a double-edged weapon. On one hand, you do get a lot of benefit, but it has to be handled carefully so that you get the desired result.
No, thank you. Thank you for that. I mean, really, I think the last point, what you mentioned, Jacob, the warranty data and stuff, and I've known personally many companies, though I don't want to name them, they have saved millions just by doing this, because now their warranty is much more accurate and they're able to even identify, are they the real claimants or not? Was it because of a valid reason, or it was because of misuse, and all of those kind of reasons are getting uncovered. So I think really, I think if you really look at the 360-degree, I think AI can really play a fantastic role. I think thank you for that answer. I think let me move on to Prasad now, and Prasad from Dassault. And I know Dassault has a great platform, 3D experience. So I know Dassault from perspective. But the question I have, Prasad, for you is that, if you look at it, Industry 4.0, I think while some say it's quite advanced, some say it's quite early. I think India, especially, it's still in the early stages as compared to Europe or the US. But then I think we are really seeing great benefits from AI already. I mean, if you look at it, because at the heart of Internet of Things and all of those things, if you really start connecting the shop floor to the top floor and bring in the entire R&D and design together into a complete 360-degree loop, there's immense benefits which everybody sees, right? Now, especially coming from Dassault, since you've been working with many customers, you're one of the leaders as well. Just wanted to understand that, how do you think this industrial AI or these AI tools can help transform the manufacturing sector, focused on design and other aspects?
Yeah. So Thank you, first of all, for inviting me. And it's a great question. And thanks to Jacob for starting up with the great inputs here. I would like to look at it in a little different manner because when we look at Industry 4.0 with manufacturing, if you look at apart from India, globally, the transformation has already started. And when we look at the manufacturing specifically, there are many verticals in terms of sub verticals or components in it, which is one of the key areas which I see is industrial infrastructure as well as on the side of construction, which is transforming tremendously right now on the site. But as with the Dassault as a experienced player in the industry, we have transformed manufacturing way back. I mean, in 80s, 90s, we started off, but later on, if you look at aerospace and defense, we transformed right from the digital markup in 90s. And the whole Boeing was, digitally created before it even spec'd out or before it even, built really. And that's where the transformation started in manufacturing. I mean, that's the history of, Dassault. Later on, the same principles, if you look at the KPIs, which is time, cost, material, and the quality, today it is zero material waste, or next thing is which is net zero kind of for the carbon, efficiency, how we are actually literally achieving this. So the same principles, the same KPIs have been applied to automotive. And after transforming these two industries, we as a vision, we are currently looking at two major industries. With number one, I would say the healthcare, which is, as well as the high tech, as well as, these two sometimes goes hand in hand, but the major part comes with the construction side of it. Because if you look at the productivity, why we are doing AI, why we are doing machine learning, I mean, this is Industry 4.0 or 5 rather, we are talking about, but there are industries which needs manufacturing boost and which needs the real transformation where the productivity is less than half of manufacturing, which is construction. Today, if you look at the overall, the demand in the industry today, per day 1,000 buildings are getting manufactured, I would say, or constructed. But the world is going to change very soon. It is going to be a DFMA kind of a process, which is very similar to the assembly lineup, what we see in automotive as well as in the manufacturing space. And the biggest lacuna, if you see why, Dassault is looking at it, because we are detail-oriented company. We are a scientific company, and we always simulate the whole thing before it is being built, whether it is car or aircraft or anything. So today we carry the vision of transforming construction in the manufacturing way and applying those successful processes or best practices which has been followed in the industry and apply it here. Now you look at architecture side, many people use artificial intelligence kind of tools, which is called generative design or generative experience in terms of. So that's where the biggest transformation is happening, where at concept level, how you can produce faster buildings or faster infrastructure with high amount of detail, which we call LOD 500. So that is where we are focusing currently, Neeraj. And thanks for asking this question, because this is something we really would like to transform.
Thank you, Prasad, for this question. I think I like what you said, that, you're looking at, bringing in the concepts of, say, automotive manufacturing to, say, construction. So, and that's where the speed and efficiency coming in. So very interesting. Probably we'll discuss more on that.
Sure.
As well. Thank you for your answer. Fair enough. So I'll move next, and then I'll again come back to this question. So my next question is to Girish, and Girish from Tata Autocom. So I think for you, I think design is a kind of day in, day out thing, right? So I think it's like, you must be doing it every moment. But I think the question I have for you is that, you have a concept, and from a concept, you have to convert into a high technology or a kind of what do you say, digital products and all of those things in today's world, right? So there are a lot of what do you say, hard work, procedures, steps, and stuff like that, and the first output is never the one which works. So there's a lot of iterations and simulations and all of those things need to be done, right? So how do you really man? So I think the question is basically, how do you really leverage these simulations and stuff like that, and how does it really help you in your design approach of the process you follow?
Basically, we're into automotive. AI is still, we feel we are still far away from AI because we need to deliver right now the products, and still the data, what we have collected is very less. We need to go far ahead to collect the data and analyze and those things. We do still in the conventional way of designing. We do simulations.
Yes, so I think talk about the simulations. Let not be the AI, maybe the simulations. How do you do the simulations, and how does it really help you? I mean, the software simulations and stuff like
Yes, yeah, those things we do a lot of things. Without that, the design will not be completed.
Yes.
Those are the things which are the tools where we reduce a lot of physical destructive testing that help us a lot in validating the product and do the product to meet the customer requirement of quality, cost, and delivery. And these softwares will help us to build in the flexibility so that we can do a lot of iterations and make the product robust. And we use a lot of simulations like static, dynamic, and other simulations to validate the product in the process.
Thanks for that. So moving on to Senthil from RSP. So Senthil, I think just a corollary to that. So basically, I mean, while we're doing all of those things, right? I mean, we can have all of the strategy, design strategy, manufacturing strategy, and stuff like that. But end of the day, your design should be producible in the most efficient way. So what's your view on design for producibility? Any thoughts on that?
Thank you, Neeraj, for inviting me for this session. Before going to answer your question, I have one small appreciation for this session. See, I read recently the human library, the word human library. So the human library replaces the books, and we can able to interacting with the persons to understand what we want, and maybe in a very instant time and a very efficient manner. So this session is almost looks like the same kind of a human library. I can able to read 10 books in 1 hour. That is what I can able to see by your way of asking a questions, and people are answering. It's really a very interesting thing. It's thanks for that. And see, answering your questions, right? Manufacturability, right? If we are going for that. See, there are, see, I worked in different organizations in my career. If you're going to see the product which is going to be developed before going to be developed, right? We need to spend a lot of time. And see, Six Sigma is one of the tool which is very effective, and which can be used in a very extensive way to meet all your questions in a very first time, right, on time kind of a launch. So in Six Sigma, there is a tool called AHP and QFD. If you are going to use that, and that tool will be going to collect the input from the different departments. It starts from the design and manufacturing, quality, service, marketing, and field service also. So, okay, in that, no, whatever the manufacturing related things also, we are going to involve in the stage of the planning stage itself. So that tool will help really to address all the manufacturability related things, and that will be helping the robust designs with manufacturable at the first time itself. So that is the one which I would prefer to implement in all the development centers or R&D, which will help us to develop the very good product for manufacturing point of view. So that is my view. And see, I was having more relevant to the R&D related products. I worked in a R&D environment, and definitely this one point which we are going to discuss during the development or development of the planning stage itself. So I answered your questions, right? So Six Sigma is the tool we need to adapt for any product development cycles to address this kind of questions.
No, very good, very good. So I think I like the answer. I think so. This is one part of it, but I think I can also add to say what Jacob highlighted, right? I think once you start bringing in a lot of field data. So one is the field inputs, but the field means the actual products data. Then it becomes of a different league. Then you're actually solving the real problems of the customer as well. In addition, so that also we can be one addition to what you said, if you would think that's
Yeah, that's true.
right. Good. Thank you, Senthil. And let me now go to Nikhil. So Nikhil from NVIDIA. So I mean, you guys are on the platform, I think, building in a lot of stuff to enable this next generation design. So Nikhil, the first question I have for you is that what do you see as the trends, right? So what are the trends in design from your perspective? Because you are pretty agnostic. Everybody is leveraging your platform. So what would you say on the trends you see?
No, perfect. First and foremost, even before I start answering that question, Neeraj, thank you very much for having me on the panel. I'm currently sticking out as a sore thumb on the panel because I'm not an actual manufacturer. But when it comes to design, I mean, NVIDIA is 100% the platform of choice for anything when it comes to design. Secondly, NVIDIA is also, a key strategic partner to most of your favorite ISVs. So we have Prasad on the board, on the panel as well, so people like Dassault, etc. So NVIDIA is a key strategic partner. So my position on this panel is more of an enabler and not much of a user, right? Coming back to your questions around, what are the trends in design that we are seeing? See, design, and this is my perspective and my experience that I am putting forward, but design is a very, very umbrella term. It has a role to play across the value chain. So whether you're doing product design, you're doing styling, you're doing prototyping, simulation, design reviews, even sales and marketing. So, design plays a role across the value chain. But predominantly the four, the trends that I'm seeing in manufacturing or in design, I can actually think about it in four buckets. The first bucket that I foresee design trend is in having realistic photoreal designs. What that means is, hey, at the design stage, you want to have you no more want to have just a design. You want to see at the design stage, hey, how is my final product going to look, right? How is the look and finish going to be? If I use a certain material, if I use a certain finish, how is it going to look, right? So at the design stage itself, people want to see what the final product is going to be. So there's a lot of emphasis on that. This needs a lot of compute power. There's a lot of rendering play at stake in this, right? The second trend that I see is around collaboration or collaborative design. Now, design as a function in itself, I mean, if you look at whether you're designing a pen or a rocket or an automobile, whatever it is, design as a function is not a one single person job. You have multiple people working on multiple applications coming together to create that one design, right? So how do we get people to collaborate together? How do we get people to work together? And keeping the aspect of being fast, your time to market is really important. How do we cut short that, while getting people to collaborate? On top of that, when we talk about collaboration, the new curveball that we've also got is, hey, now we have the pandemic. Earlier, people were sitting in the offices, collaborating together, working together. But now, hey, people are working from home in different locations, or rather your design teams are also spread across the globe today, right? So how do you get people to collaborate? So that's another trend that, that's coming up. The third trend, and, which Prasad very rightly pointed out, was around simulated design, right? You no more just want to design the product and see what the product looks like. You want to simulate that product. So, how will it function in a certain temperature, in a certain environment? How does it look at this time of the day, etc.? So you want to really simulate that design. So simulation integrated design is another trend that we are seeing. The fourth trend, we've been talking a lot about it, is the infusion or the adoption of AI in design. We very briefly spoke about generative design. Even Jacob touched upon, hey, when we do design, we pull in a lot of data from maybe your past experiences or what the customers like, etc. And then you want to design on that. Artificial intelligence or AI is actually taking all of this together, all the information, all the data together, and helping you design. So yeah, so I predominantly think those are the key trends in design.
Thank you, Nikhil. I mean, I tend to kind of, I think everything what you said is what is the trend. I also feel so, and especially AI. I think that's going to fuel. I mean, as we go along, the extent would keep increasing. Any views from the panelists? Maybe we can take a couple of views on the trends. Do you think there are any additional trends or any points on what Nikhil mentioned? Anybody? So I was just requesting the panelists, I mean, if there's any view on what Nikhil mentioned in terms of any additional themes you think as a trend for design or...
I think Nikhil has touched upon some very key points. For us, in our designing process, what we encounter is the amount of collaboration that's coming in.
Right.
In one of the projects that we're working with a major OE, global OE, normally, as Bosch, we used to do projects where hardware and software is integrated and provided as a box. So it's easy for the OE to integrate into his or her systems and have a complete vehicle done up. What we are seeing more and more is much more powerful silicons coming into the market, which means there's a higher abstraction levels on the software front that's coming. And this means a single unit, you have around 40 to 50 suppliers coming together to make it. And this comes with a tool chain which needs to be supporting this. So what we call as continuous integration, continuous development, continuous testing is at the core of this development philosophy. So concurrent engineering is a thing which is not good to have, it's must to have now. Because you need to run all the facets together to get a product out in time. And you can't wait until one part of the output comes in and you start. That's just no longer feasible. So you need to work with multiple players and also on multiple functions on a concurrent level. And you need to have an ecosystem that supports it. That's the key. The backbone of all such is processes and systems that can support you to do such activity together, not only with internal stakeholders, but also outside your boundaries. This we see more and more. And as much as the complexity of product is changing, with data engineering at the core, so is the mode of collaboration that's changing at a very, very fast pace.
No, absolutely, Jacob. Thank you for that. I think that's quite useful, I think, for our audience as well to understand, all these concepts. So thank you for that. Any other comment, or I think I can move ahead if...
One comment, Neeraj, a quick one. When we look at, Nikhil classically mentioned the four trends, but I would like to bring in a little different view here in terms of not exactly the trend, but I would say it's a practice which is getting developed quite a lot. That since we are talking about generative design, AI and ML, if you look at from the designer's point of view, whether it is a car or aircraft or construction, which I predominantly come from, I see architects today are inspiring the designs or getting inspired with the nature, and the kind of designs are coming up which are very complex and which never used to be possible. For example, one of the, let's say, buildings inspired by some kind of a shape of an ant, or I would say the kind of the kind of insects we have. I mean, people really would like to take the benefits. Or even if you look at in automotive, the front nose is more inspired by the shark, and that's how people call it. It's sharky eyes or sharky headlights or something like that. So when you look at all these things, very minute level of details are required, to be developed and manufactured. And those, if you are designing, always say it's a concept. In automotive, in architecture, it's again a concept. So the design process is same across all the industries. So how fast you move from the concept level to the deliverable level, or how fast you can really take that design in the first phase itself to the manufacturing level, that's the biggest challenge today. Though we have AI, though we have ML coming up, that might help take us the decisions. But when it comes, because when you produce one design in generative experience, people who are coming with the old school kind of thought, they will not like it. I mean, they'll say, hey, this is not the right thing which I would like to do it, but this is how you used to do it with the other methods. But yeah, that's how the industry is shaping up. So I would like to make a quick point here that the tools are important, and Dassault is focusing on how detailed oriented softwares or the platform, 3D experience platform, can be made for the designers to really bring their the dreams possible. Because when you conceptualize something, only 60% or 70% gets materialized. How that concept can be 100% deliver is the effort I think we are all looking at. Thank you, Neeraj. Thanks for that.
Hey,
Thanks.
sorry. I just want to take a lot of time, but Prasad, that was a brilliant point. And, I just want to bring this out. What you said is exactly right. From the concept to the actual product being made, the NVIDIA headquarters, okay, and it's an amazing case study. You guys should maybe try Googling it up. The NVIDIA headquarters is being made in such a way in the US, in Santa Clara, that it's already there. It's already ready now. In fact, we just opened it. It has been made in such a way that you maximize the use of natural light to an extent where we only use, for lighting purposes, we only use 20% of additional power. Everything else is sunlight. So this building was first created, then it was simulated, then they made all these changes, to accommodate the maximum sunlight, etc. And now it is ready. The building is actually there. Of course, it's an AEC example, it's an architecture example, but I just thought I'll bring that out. So yeah.
Thanks, Nikhil.
Perfect.
No, good. I think you guys have brought in a very different perspective as well. So it's like, one is, I mean, of course, we talk about AI and we talk about all of those things, but I think the point, what Prasad, also made, that, making that, I mean, providing that enablement, right, via technology or by your platforms, so that every possible detail, right, you can actually, imagine, and you can actually put into, the design or the reality which you want to achieve. So amazing. So I think, thank you for that. So just a question to the RTP Media team. Should we go ahead with the poll now before we get into the next set of questions?
I think if we have any few questions, I think for Nikhil or other gentlemen, maybe after that round, we'll take the poll.
That's fine. That's fine. So, okay, no problem. Then I'll
maybe
go ahead.
we are waiting. Mr. Chinnaraja just sent a message. He's somewhere where there's a network issue. He's also traveling, but he's taking the call. Maybe he can join by that time. Let's have one more round. Thank you.
No problem. Thank you. So let me go to the next round of questions. And I think this is again to Jacob. And the question is around strategies, right? We talk about Industry 4.0 strategy. We talk about, a lot of things, manufacturing strategy, design strategy, so many strategies we talk about, right? But ultimately, I think we have to make it successful. So according to you, coming from Bosch, what is the DNA, or what do you think are the snippets of a successful strategy, digital strategy?
I think keeping customer at the center. You don't make any strategy just because you have a tool. Otherwise, you will end up looking at every problem like a nail. The key aspect is not just copying what possibly succeeded for some other company, but integrating it into your ethos and your strength and seeing how it provides value to the consumer. So for Bosch, we are a very strong products company. We make products which make people's life easier, whether by giving them a great experience of washing the dishes or washing their clothes, or making a power drill, or making your automobile safer. The way the digital has to be brought in is either in a way that it provides a great experience for the consumer. So That's through the mode of delivery. Fundamentally, one of the decisions that we took very early, almost 6 to 7 years back, was that all our products are going to be connected. For any digital strategy to be successful, at the heart of it is that you need to have data. So you need to have data that you collect. Then you need to know how you're going to consume it. And finally, you need to have some way of making intelligence so that it provides value to either the designer, the manufacturing, or the consumer. So this value chain has to be understood. So first decision that we took was that we would connect all the products. The second decision that we took was that we play on the data in the cloud. So we went for an hybrid strategy where we had our own cloud, plus we have collaborated with all the big major cloud providers in the game. So it's possible that for certain part of the data, the problem with the data is some of them have to be protected, while some of them can be left open in the public domain. So certain part of the data which is very key for us and which could let us control our IPs, we keep it in our cloud, our private cloud, while for most of the big crunching and algorithms that are already public, that we work on the public cloud. The third part of a digital strategy is partners. This is a game that you can't win without partners. You can't do it all. So you have your strength. You need to also understand strength that you need to get in from partners. So these partners could be startups. They can be companies like NVIDIA or the IBMs or the Amazons of the world. So this is the third part that we brought in with. We had partnerships that we drew up for different parts of the digital value chain. And at the end of the day, we look at what is the value, as you said, that we give to the customer. Like for us, we have a baking oven. Now, by giving a connectivity to baking oven, what value do you give? Nothing. It's just connected. That's all. It's more of a fad. But what if you give a value to a consumer that he or she can bake a fantastic cake, like the best chef in a certain hotel. Now, this means there is the ingredients that goes in, and there is a temperature curve that needs to be maintained so that you have the right product. Now, it's about a wow experience that the consumer gets. So here you have a play of the content of the ingredients which needs to be at the proportion that needs to be controlled, and there is a temperature curve that needs to be controlled. And all of this happens together, then you have magic of digital providing you a cake that you can enjoy with your family. So this is the key. A digital for digital sake possibly will not get you anything other than a connectivity and possibly some amount of, you may not get any value for the consumer. So for us, at the heart of our digital strategy is what is the value that we give to a consumer.
No, thank you. I think definitely it's heart of it is value to customer, and I think nobody can do it alone. So we need to have partners and everybody coming and contributing to be able to make your own digital strategy a success. Right? Now, going next to Prasad again, and I think we briefly touched upon simulation already, but I think just kind of getting into maybe a little bit more details now. That we talk about simulation-based product development today. And I think there was concepts of lean, there were concepts of increasing efficiency and all of those things. So simulation, how does simulation-driven product development benefit the end customers or the end designers in the process? Some thoughts on that, Prasad.
Sure, Neeraj. So simulation is I mean, the whole thinking of simulating the whole engine, or whether it is simulating the overall whatever you're building or a product, right from, as Jacob mentioned, right from the washing machines to any other industrial design for that matter. I mean, before it is real, before it is been manufactured, how it really performs. That is one way of looking at simulation, or looking at more from the pressure analytics, right from your fluid, right from your stress analysis, right from the aesthetics or the weathering effect. I mean, it needs to be simulated in a real time. So if I look at from the manufacturing point of view, this is already being practiced heavily. I think, I think one more person on the panel as well mentioned about it needs to be simulated. And this particular thought process now slowly, steadily, in fact, very rapidly these days, for the last 1-2 years, coming to construction, it's a simulation of constructability. For example, you're building, now you heard of big bridges are getting built in India. For example, it needs to be simulated and with the time connected to it, and how the entire material can be reached to that particular site. So this is not known to most of the construction industrial entities in the past days, but today there is a big need. Though they use the CAD, they use the 2D data. Now the simulation things starts from when you have the data in 3D, where whether it is a digital twin, which is a fullest functional model. So this is where it can differentiate between the digital twin and the virtual twin. So digital twin is basically, which is probably for the manufacturing purposes or for the construction purposes, which is called construction twin. But when it comes to the virtual twin, it's a functional model. This is how it is going to function, and you see everything before it really gets constructed. Now there is another aspect to the twin, which is maintenance twin. I mean, when it comes to the maintenance part of it, this is where the AI and ML comes into the picture for the predictive maintenance. If you have the sensors fitted on that, IoT sensors fitted on that, so you get to know the maintenance part of. So there are 2-3 aspects of having it simulated. The maintenance today is being simulated that another 2 years down the line I would need so and so hinge, or the warranty of so and so pump is getting expired and I need to, though it is really working in a good condition. I mean, most of the times we always do the breakdown maintenance. So to avoid that and to have the less pressure on the budgeting, it needs to be simulated. So simulation is not only from the design point of view, even from the financial point of view, that the finance needs to be simulated in a way that tomorrow, if this is going to be the situation, how much budgeting I need to do today. So it's been linked right from your supply chain, from the store management to everything. I mean, it's a vast topic to really look at it. So thanks for asking that question, and this is where my answer is. Thank you.
No, thank you, Prasad. No, I mean, I think it's one of the key themes, I would say, for the designers today, to kind of simulate the different options before you start getting into actual manufacturing or actual making of it. And I think you explained beautifully the digital twin, virtual twin, and more importantly, the maintenance twin, because there are different terminologies and it's good to understand. So thanks for that. Moving on to Girish. Girish, I think the question I have is, I think, more from an automotive perspective. There's a lot of concept. I mean, there's a lot of talks of agile design and stuff like that. The ease of manufacturability and so on and so forth. So how does your agile design or what kind of agile design approaches you think are really helping the industry today?
Yeah, agility comes from the design stage itself. That is true. Demand from the customer or the final user is they require ease to use, and it should be ease for assembly, disassembly, and it should be aesthetic and good. A lot of things come in. It should be robust, should be durable, and these things can be done at the drawing board itself. So using CAD, CAM softwares and doing simulations, doing all the putting inputs on the table, discussing with the customers, and we can achieve this. Thing is, now there's a lot of demand from the customer, even the end customers in automotive. People come up with crazy ideas and they want a lot of options to be incorporated in the. So we need to be a little bit well ahead of these things and get the voice of customer and input all the data into it and make it good product. So we need to do a lot of homework and use a lot of experience and put in our brains, brainstorm it, do a lot of simulation work so that the product should be, that's all I can.
So moving on, I think, Senthil, from your perspective, right? Just to kind of understand, see, design is very strategic as always, because, that's where you start, right? So it's a very strategic, process. And, it, the design can really have long lasting influences on sales, your field, your repairs, your manufacturing and everything. So, so from your perspective, how do you make sure that your designs or the design what you are making is viable? When I say viable, it means it can be manufactured well. It's linked to the thought process of what the customer wants, and meeting up to the objectives of its own design parameters. So, because ultimately it's the company's own viability if the design is not viable. So if the design is not viable, it might reflect on the reputation of the company as well. So how do you make viable designs? Any thought process on that?
It's good, actually, good question. And see, the customer wants and needs, right? That is one of the process which we need to adapt during the initial stage of the design and new product development. So if we are going to discuss, see, what we are doing currently, we are manufacturing a product for some of the customer requirement, right? And that customer requirement should be captured in a right way and systematic way and scientific methodology. We need to adapt, and then we need to capture those things in a very systematic approach, and we need to hierarch those things also. See, sometimes the customer is going to ask me, I need this, I need that, all those things. Sometimes no, that is not going to be come under the cost pressure also. See, I wanted to make all the features with X price. It is very difficult also. So what we need to do is we need to capture the first customer wants and needs on the product, and then we need to hierarchy. We need to do what is the priority they have within the 10 requirements if their customer is going to put, and we need to ask them to prioritize those things. What is the first priority? What is the second priority? What is the third one? So with that information, we can able to decide which one we need to be keep as a priority and the specification of the product. Once we derive that, and then we can able to go for a concept designs, and then we can submit those things for the validations or the alpha level prototypes can be tested, and then we whatever the failure modes which we are facing those things, we have to list those things, and we have to share with the customers. These are the things, if we are going to use this kind of a specification, these are the failure modes. Whether we can able to robust, we can able to strengthen certain things with our designs, and we can able to revisit our designs, and then we can go for a beta kind of a things. So this is the way I can able to say for developing a product for the customer's requirement.
Moving next to Nikhil again. So Nikhil, I think this question is something which even I am interested in, because with the pandemic period, right, which just got over, or we assuming it's still over, right? And specifically when we look at design, right? I mean, all these different tools, the 3D tools and stuff, they're really, really high resource consuming tools, right? And people have to work in secure environments, because this is also IP of the companies who are building this designs, as we go along. So, so one side you need high resources to be able to do this 3D modeling. The other side, it's an IP. What's your thought? How did your company support these, working from home, providing these high resources, and not let the productivity get dropped? Because if that gets dropped, then I think it's a hit on everybody's, top line, bottom line, whatever.
Thanks, Neeraj. I mean, I was actually hoping I was actually wondering rather that, we've not still spoken about remote work, work from home, because every discussion that you have today is more or less centered around, this as a concept. But, if even before the pandemic, even before these terms became mainstream, remote work, work from home, etc., right? If we go to the pre-pandemic era, enterprises, if you think about it, were always talking about, hey, how do I get my users to work from anywhere? BYOD, or bring your own device to work, being able to work on any device. That was like a key feature. Security was always on the minds of enterprises. It just so happened that the pandemic just made it not a good to have technology, or it just made it like a must have for you to do your life's work. Now, the way that we are basically seeing the so-called remote work or work from home strategy, a successful remote work or work from home strategy. Again, my take on it is based on 4 pillars. The first pillar for a successful remote working strategy was around mobility. You had to be able to get your designers or your people or your creative people to be able to work from anywhere. Right? I mean, they were like designers. If you typically look at them as a profile, designers would typically walk into the office, they would be in office, they would be accessing their beefy workstations and then going back home, right? But now people had to be able to work from anywhere. So a successful mobility strategy was in place. The second pillar was around performance. Just because you're working from home, you no more have access to, let's say, the high-end resourceful workstations that you have in office, was not an excuse for you to do substandard work or your efficiency to drop. So, getting your performance, letting your performance be at the same level, that was the second key pillar for a successful remote working strategy. The third was around security. I'm very sure, like if you talk to Jacob right now and you tell him, hey, you know what, your design or your core IP of your organization is the design, and it's going to flow out of your secure premises, I'm very sure it will give you some palpitations. Enterprises are very, 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 very protective about their core IP or the design, right? So how do you have a successful security strategy? Now, the fourth pillar that I want to talk about is manageability. And this is an example that somebody gave me. In fact, one of our customers gave me. Like if you, for example, had a design team of 100 users sitting in one single location, after the pandemic, when the people started working from home, it turned into 100 office locations. So your IT team, which was, let's say, about 2 people or 4 people that were managing these 100 users, suddenly had to manage 100 locations. So manageability of your design team or their design infrastructure also became very important. So any technology, not just the NVIDIA technologies, but any technology that got enterprises to not compromise on any of these pillars and continue working, I mean, that is the technology that really helped customers. We saw a lot of customers move to the cloud. We saw, in a knee-jerk reaction, we saw a lot of customers ship those workstations to the user's home, give them high bandwidth, etc. Right? But any technology that did not ask you to compromise on any of the 4 pillars, that's mobility, performance, security, manageability, redefined your remote working experience. Now, of course, when it comes to design, like when I introduced, I said, hey, everybody uses GPUs or NVIDIA platform for design. Now, NVIDIA has a technology that lets you stream the capabilities of a GPU to any user to work or any device, not necessarily the same device. It's called the virtual GPU technology. But that was the technology that really turned table for a lot of design users across industry verticals. And of course, manufacturing was a key vertical that benefited.
Thank you. I think that's that's the, fundamental. I think, enabling, people to kind of, that's where the use of technology comes in, that, create that environment in which, you can actually function and you don't let your productivity go down. So thank you for that. I think going on next, and before I go on next, I just wanted to check with, Sanjay and team, do we have the
Nikhil,
now?
we will run the poll.
Yes. Okay.
Just give us a moment.
So we take a pause here before, and we take a pause for this poll and then we resume. So request people, who are attending to kind of take this poll and enter your choices. So it looks like many people are exploring virtualization. They don't have it done yet. And also AI ML is something which is getting there. almost 3/4 of the people here do not have it. Good. So moving on next, and I think I'll probably try to now get into the future, right? Even beyond what we are today. And I think I'll again go back to Nikhil. Uh, so while today we are still in the physical world, we are leveraging technology to do design, development, whatever, manufacturing. But I think, as metaverse comes into picture, right? I think it's not just meetings. I think literally everything is going to happen in the metaverse, right? So what it means is you might look at a collaborative design happening in the metaverse, right? Now, while it looks the future, but my personal feeling is that it's not even 3 to 5 years. I mean, it's just a matter of time. It's there. So what, I mean, how does technology and how do you think a company like yours can support, a kind of collaborative design, working environment, leveraging AI or other technologies uh, to help achieve the objective in the metaverse or 3D worlds coming together?
Right. No, perfect. I mean, again, this is the new buzzword that everybody's talking about, metaverse, 3D worlds, etc. But coming to the core of it, hey, when we talk about the metaverse, as a layman or a simple definition, well, it is going to be an exact replication of your it's a 3D replication of your real world. I mean, everything that's in the real world today, your cars, etc., you would want the same in the metaverse. Now, a lot of it, of course, most of it is devised by artificial intelligence. AI today is pervasive across industries, across workflows, across workloads. Every industry, every business function, everything is being touched upon by AI. But coming back to your question, how do you see that implying into the manufacturing industry? Now, let's think about it. For the manufacturing industry, what is really critical? Quality, agility, scale, efficiency, all these are really critical factors for the manufacturing industry. You have globally dispersed teams that need to make a lot of critical decision, not just around design, but design simulation around the actual manufacturing of the certain product, right? Also, what teams basically need to do is they need to synchronize realities between, hey, what is digital, how is it going to be in the physical, etc., right? Now, to bring all of this on a single platform, okay, that becomes a really big challenge, and all of this on a single platform where you can simulate it in a 3D world. So that is the bigger challenge. Now, from an NVIDIA perspective, of course, we have, please Google it. We have something that we call as Omniverse. Omniverse is NVIDIA's own 3D collaboration real-time platform for you to, I mean, it enables multiple use cases. I'll talk about a few, but that is something that is helping people simulate what they want to do in the 3D world, right? So a couple of use cases that I would like to talk about is, let's say, design reviews. You have people working across the globe, let's say on a single design, multiple applications. How do you get these guys together on a real-time 3D collaborative platform? That is something that Omniverse does. For example, if it's a car manufacturer, somebody is designing the headlight, somebody is designing the interior, somebody is designing the door. How do all of these guys come together in real time on a single platform across applications? So that is something that is being done. The second thing around manufacturing that I foresee is supplier communication, right? Your suppliers are somewhere else, your designers are somewhere else, your customers are somewhere else, right? How do you get all of those guys together right at the design stage? How do you get your suppliers to be well informed about, hey, these are the design changes, and accordingly, the materials need to change, or products need to change. The third thing that I see a lot happening from a metaverse perspective is around artificial engineering training and simulation of robots, right? Your manufacturing shop floor today is filled with robots. I mean, I'm sure Peter can talk about his, Jacob can talk about his thing, but so how do you get these robots to learn, or how do you get these robots trained, right? So that is something that you can do in the metaverse as well. The fourth thing that I'm seeing happen quite a lot. And of course, digital twins is one way to call it, but visualizing your entire factory floors and then, simulating the factory floors in such a way that, it comes to your advantage. Like we have a BMW factory that we simulated, right? And all they really figured out was, hey, there was a conveyor belt, and they had a stand at the end of it. They just had to drop the stand by, let's say, a couple of feet for their productivity to go up, let's say about 1% up, which is a huge bump. But you could do it because you could simulate that kind of thing. So all of that is today possible to create in a 3D world. Now, when you talk about AI from a manufacturing perspective, I know it could just be a summary of what a lot of people have already spoken about, but AI is playing a major role, in design and simulation, for example, materials, chemicals, aerodynamics, the actual manufacturability. So AI is playing a lot of role in design and simulation. The second domain where in manufacturing that AI is playing a lot of role is around smart manufacturing. So, quality inspection, robotics, process control, worker safety, etc., like plant autonomy. Though these are some of the use cases that AI is driving in smart manufacturing as a domain. The third area that I'm seeing a lot of AI basically get infused into is supply chain and logistics. So, material handling, forecasting, inventory, warehouse management, there's a lot of AI play there as well. And yes, and some people did talk about it. There is, on the final frontier, there's a lot of play that's AI play that's happening in service and maintenance. So, your field inspection, predictive maintenance, your asset tracking, or even document analysis, all of that. So if you look at it end to end, there is a use case for AI in every stage of manufacturing. And of course, you do have a metaverse and a 3D play as well. So yeah, so that would be my answer.
No, thank you. This is interesting, and we have to see how it pans out. But I want to ask Prasad, Prasad, I mean, the digital twin, the virtual twin, the maintenance twin, how does it pan out in the metaverse?
So when it talks about metaverse, I only see one point, which is scalability and the scale of things happening at once. I mean, that's how I would like to relate in a very simple words. And if you look at from the the collaboration point, what Nikhil touched upon, is the today's biggest gap right now, I would say, because I'll take a little more minute here, Niraj, because this is really close to my heart to explain and how things are happening here. And if you look at currently on the 3D side, okay, people have only looked at the visual aspect of it, or how beautifully the animation is done, or the walkthrough is done. That's the limited knowledge of the audience, I would say. I mean, not the designer's point of view, but that's how people would like to perceive. But here the things are completely different. And when it comes to the scalability, which I mentioned, right from your automotive design to the aerospace and defense, we have already transformed these things in the last 10-15 years. I mean, people know about it. They live through the design virtually through the best possible scenarios which has been created for that design's viability, which you have been mentioning about how the design can be more viable. So it has got many aspects, which is cost, which is production ability, the scalability, the sales comes into the picture, the demand comes into the picture. How are you going to market it? I mean, that's a full spiral of the whole process, what you see. But when it now if you look at the design as a core, we have seen the outer part of it, but when we see the design as a core, people are using many multiple products. I mean, I would say right from CAD 1 to CAD 2, it's a multi-CAD platform right now. People are using lots of data exchange, lots of this file doesn't get I'm sorry, I'm getting a little more detailed here, but this file doesn't open up here. There is a data loss, there is a metadata loss, and so and so forth. So huge challenges in front of them, and people are now looking at with the help of cloud, because the IT has really brought that difference here. And that's what Nikhil was also pointing it out to their GPU, and how we can utilize the cloud platform. Now this is where is the time people now realize the use of platform, that I cannot collaborate very well. I cannot utilize the stakeholders' designs. It is still banking on emails and the FTPs and the file drives and a lot of things. So the missing link here is a platform. And lucky that I am with Dassault Systems today, and I really see the power of 3D experience platform here, that you don't need to really think about being collaborative. You are already collaborated. I mean, the design, imagine you have the whole 3D model right from the micron level to the kilometers level, which I'm touching upon the infrastructure side of it, or the construction side of it, or the city. For example, Dassault system is having 3D experience city solution that you can virtualize the whole city. You can build the whole city and simulate for the purposes of city planners and everything. So when it comes to the collaborative aspect, there are multiple side of it, right from the citizens to the designers to the approval authorities to the supply chain to the contractors, and many stakeholders come into the picture. So here the collaborative platform is important, and imagine that you are designing on the platform in the browser. That's the power of cloud. That's the power of 3D experience platform, which I would like to bring in topic today. So this is where is the biggest differentiator when you talked about the metaverse of the scalability, or how much complex it is going to be. Imagine the amount of data it is creating every day. So the data centers again come to the picture. So it's a huge network when it comes to the 3D metaverse, what we are talking about. Thank you, Neeraj. Thanks for the time.
Oh, thank you. I think it's interesting because I think this platform is the key, once we get into the metaverse. And today, I know the challenges you talked about, the different CAD tools not talking to each other. And I think we have a lot of ground to fix first before we talk about metaverse, but then it's eventually it has to be there. So it's a matter of time. So thank you. I think, thank you for all the wonderful insights, you guys have given to me and also the audience today. I mean, I have few takeaways which I can relate to, and I can just go through it to sum up, and then we kind of open up for some Q&A. Thank you very much, all of you. Indeed, I think, from Jacob, I think good insights. He talked about how he's bringing in AI in the process of modeling and bringing in low code, no code kind of situations. And not just that, he also talked about bringing in a lot of warranty data and stuff to be able to kind of do predictive analysis, analytics, and things like that. He also talked about, when you look at the strategy of a digital strategy, the heart of it is, I mean, the core is customer. So I think anything you make, it should be connected to the customer. Very often we forget that. So I think it's an important reminder from Jacob that, don't forget that. And finally, he said that, you cannot do everything on your own, right? You have to bring in your partners, and you have to have your ecosystem in place. So that's, I think, very powerful statements and very leading, thoughts to make someone successful. So thank you, Jacob, for that. Appreciate that. Prasad, I think, it was really a pleasure. I think you talked about many things, from simulation to transformation, collaborative platform, and more importantly, I think, the way you described the digital twin, the virtual twin, the functional, the maintenance twin, basically. And then I think I was happy to hear your views that how these twins would actually end up working in a metaverse. I know it's a far-fetched reality, but it has to work one day, and that's the way it's going to go. So thank you for that. Girish also talked about simulations, static simulations, dynamic simulations. And I think one thing he mentioned was important, that he talked about agility really comes from design. So I think the first step is design. You're thinking about agility, which is very important. You don't have to really think about agility later. And I think he talked about how he leverages the different CAD, CAM softwares and have those ongoing discussions with the customer. And then I think, as we go along, you build up a plan to, finalize or complete your design. Senthil, again, I think he talked about some very good points that, how to get first time right. And I think he talked about some Six Sigma processes, getting feedback from different departments, including the field, to set your design for producibility right. He also talked about different models. I think how to really produce those alpha models and bring in those failure modes, and how to kind of charter those out to strengthen or revisit those designs as we go along, right? So, and Nikhil, I think finally he gave very, very good points in terms of the trends. So I think he talked about how to make it realistic. Right? In today's world, it's all about real photo, real design, right? It has to be collaborative. I mean, it has to be simulated, because simulated means with those functional parameters, the temperature, pressure, all of those kind of things, and AI, right? Finally, which has to be adopted in the entire process. And I think this was in conjunction, I think, with Prasad as well, who talked about this generative design using AI and things like that. So very, very insightful. Also, I think Nikhil talked about some of these thoughts on how the platform is helping people be mobile, work from anywhere, in a secure environment, because security is important, design is critical, is very close to the company's IP. I mean, it is the IP, and how technology is helping us overcome that. And finally, I think all these 3D or metaverse, how NVIDIA is thinking about it, and he talked about his own platforms like Omniverse and so on and so forth. So very interesting. So thank you very much. I think I think the topic for today, basically the design, collaboration, and innovation. I think we really covered it very well. All your thoughts are well appreciated, and thank you for that. With this, I would like to once again thank ITP Media and my fellow panelists, and open up for Q&A.
Thanks, Neeraj. That was a really good summing up of this discussion. There are a few questions which has come. In the interest of time, I will just take up two of them. We have a question from Shraddha, who asks, what measures are needed to implement 4.0 in automotive industry? Jacob, you would want to take that question?
Come again, I didn't get the question.
What measures are needed to implement 4.0 in automotive industry?
The key measures is, first of all, understand which areas you would like this to be implemented. Industry 4.0 is a broad term for a set of interventions that typically are done, and it also goes by the name of smart manufacturing or connected industry. The intervention can be from resource leveling, demand planning, demand forecasting. So you first have to evaluate your processes and your chain, and what are the crucial aspects that you would like to improve. Because Industry 4.0 in its whole implementation would be just a waste of money. So you will have to evaluate for your kind of manufacturing setup, where will you get the maximum impact and value, and try to take that segment. If it is that in a certain industry you can connect the machines, and possibly by getting information from the machines you can improve the throughput, then you could focus on that. If it's a very volatile demand situation, then you could possibly spend more time in the data engineering around the demand projection, so that you have some head start in terms of setting up your line for the fluctuating demand. If it is on a quality process that you would like to help the connectivity, because at the end of the day, Industry 4.0 is a broad element that brings in the connectivity that you can get between the machines, between the plants and the sensors in these, and get data out and use that data to run your lines effectively. So there is no one answer to your question. It first requires a deeper evaluation. In fact, Bosch also does consultancy on that, and there are teams which does consultancy on that. I would suggest that if you really want to go ahead with Industry 4.0 connected industry implementation, I would suggest you to take some expert help first in evaluating, and then zeroing on the focus areas, and then go by pilot approach, and then possibly roll out in different plans. That's what we do. That's what I would suggest to somebody who would like to do it.
Thanks, Jacob. Prasad, I know you have to rush for another meeting, so a quick question for you.
Sure.
AI plays a big role in manufacturing the same way. What is your opinion and views about data science importance in manufacturing industries?
Data sciences is honestly a big topic which I'm not too much exposed to. But overall, AI I can talk about because coming from the construction side and little exposed to manufacturing in my career time, uh, that's the next phase because that's where you put a constraint and lock the design ability, but still the iterations gives you the best possible designs. One anecdote I would like to share here, or an example. Recently we worked with a developer and in India, best part is that, and we are working on building or taking the design on the developer investment. For example, you are the builder and you are a developer of 6-7 sites. You can name any builder today, and which is the building which will have most sellable area. I mean, it's easy to calculate all these things. That's what we say or think, but it's very complicated. And if you have iterations, what are the best possible furniture layouts, best possible window layouts for the sunlight to come in? I mean, there are so many constraints in it, and people expect with the click of a button to happen everything the moment you take the name of AI and ML, and that's not true. And you will have to write lots of codes and kind of a algorithm with the rule-based engines in it. So it takes the right decisions, and ultimately when you look at it, it's not whole automatic. It's, I would say, it's semi-automatic, but it gives you, the developer, a clear view that which site or which project is going to be more profitable for me. Again, I'm connecting the AI not only from the design perspective to the investment point of view, and that's where the real transformation is going to happen. And I think Jacob also mentioned very clearly on the supply chain and the ability to have minimum vendors, because it's the same thing for the developer. Nobody would like to have 4 or 5 vendors for supplying windows. I mean, probably 4 or 5, but the specifications may change. So it's a huge game of level of detail, which is to be controlled by the generative design. Again, we connect the AI engine to it. So thank you, Sujata, for that question. But I don't think so. I could touch upon on the data sciences, which we are working with data centers at this point of time, but not really. I'll not be able to answer that. Thank you.
So I think I can just add on, Prasad. Basically,
Yes,
if you look at it, in the, say, pharma space or CPG space, I think, in the product development process, there are a lot of trials, a lot of things which happen. And I think in today's world, data science is playing a key role because, previously those trials used to take a lot of time. But today with technology and AI, you can predict, this molecule, this was produced, this compound. So a lot of those clinical trials and stuff like that, time is drastically getting reduced with use of data science and AI to be that respect. So I think there are different use cases which are, you just thought I'll add to
Thank you, Neeraj. With that, Sujata, I'll drop off. My meeting started.
Thanks, Prasad.
Thank you so much.
Thank you.
Thank you, everyone. Bye-bye. Bye, Nikhil. Catch you later.
The last question is for you, Nikhil. How design is going to help making products user-friendly, sustainable, cost-effective, compact, with shorter time to market? And also, would like to understand the role of design in product material recommendation and selection?
That's a pretty elaborate question in itself. But I mean, forget about design. If you ask any manufacturer today, hey, what do you really want to do? Any manufacturer will tell you that, hey, I want to get faster products to the market. I need to get products out that will sell. I need to get products out that, have a lot of features, etc. Now, if you can make those decisions in the design stage itself, then it becomes really important. I mean, it becomes a very, very valuable proposition. Now, today, thanks to, let's call it artificial intelligence, data sciences, let's call it simulation technologies, whatever you call it, the whole idea of design is that, hey, at the very first stage, at the very first design stage, you are able to make a product that suffices all your parameters. Now, that today is possible and that is where design plays a very, very critical role. So, you want to figure out, hey, basis the raw materials that are available in the market today, whether, what do the customers like, the data sciences piece, that's what Jacob was also talking about. We get a lot of customer feedback. Can we do that? Can we customize our design? Attention to detail. So all of those aspects can come into design, and it's pretty much possible for you to create a product that is faster to the market and faster off the shelf as well. So yeah.
Thank you, Nikhil, for that answer. With that, we come to the conclusion of this session. Thank you, everyone. Thank you all my panelists and Neeraj to moderate such an interesting session. And thank you all the audience.